All right, so we're going to continue on with our population unit, still focusing on humans for the rest of this unit. We're going to finish this unit up in this video. So we're going to start with 3.7, which is total fertility rate, which will just be TFR for the rest of this. And quick definition there is just it's the average number of children a woman is going to have in her lifetime. And you can see, looking at our graph from about the mid 60s, we've had a steady decline in that TFR number worldwide over the last few years. Okay, so we could see back here in the 50s, the average was all the way up here at like 5 children per woman, coming all the way down, almost half, okay, to 2.5%, or 2.5 children, not percent. So I want you to think about why that could be. So today we're going to explain factors that affect the total fertility rate, and then you're going to describe patterns or trends in data. That's going to be a really important skill for the rest of this unit. So like I said, total fertility rate, just the average number of children that a woman's going to have in her lifetime. So if you think about it rationally, if we have a higher TFR, we're going to have a higher birth rate, which means we're typically going to have higher population growth. Then we have this thing called replacement level fertility. So this is just the total amount of TFR required to offset deaths in a population and keep the population size stable. In developed countries, which we'll talk about the difference between those developed and developing and undeveloped countries a little later, that number is going to be about 2.1. So you need just enough to replace the mom and dad, but that 0.1 is going to be there for any children who will die before they reach reproductive age, or to account for the people who aren't having children. So if you think back to our age structure diagrams, this is going to be the one where our pre-reproductive cohort and our reproductive cohort are about equal. And this is going to be higher in less developed countries. So instead of it being 2.1, it might be 2.5 to 2.7, because in less developed countries, we're not going to have access to water, or clean water at least, healthcare. We might have more limited food resources. So we see more infant mortality. So people have more children to replace for those children that they're losing. So when we talk about infant mortality rate, that's the number of deaths of children under 1 year per 1,000 people. Like I said, that's going to be higher in less developed countries, and that higher IMR is going to lead to a higher total fertility rate because we're going to be replacing those children. Maybe we need them to help out around the house, or we live in a society where we're growing our own food, so we need them to help with tending crops or livestock. So they're going to replace those infants that are dying early. When we look at these graphs, we can see a really strong correlation between these two graphs. So over here we have our global total fertility rate, and over here we have our infant mortality. You can see that we've got these light orange areas, which are going to indicate a lower TFR, are going to correlate very well with our light blue areas, which means a lower infant mortality. But if we look at these dark orange areas with our higher TFRs, we see they're also darker over here, indicating more infant mortality. So there's a very strong trend or correlation between these two graphs. So infant mortality plays a really big part in total fertility rate, because as that infant mortality rate has gone down, we also see that TFR going down. So some factors that are going to affect this IMR are going to be things like access to clean water, access to healthcare, so hospitals, vaccines, supplements, and a more reliable food supply. So when we look at factors that are going to affect TFR, we've got two big factors here. The first one is development or affluence. So our more developed, wealthier nations have a lower TFR than less developed nations, and that's for a lot of reasons. The first one's more educational access for women. So women are going it's got a few things that we have to look at there. Women are going to have more reproductive knowledge, which is going to lead to less unplanned pregnancies. Women with higher levels of education tend to have more economic opportunities. So maybe they own a business or work a very demanding job, so they're less likely to marry early in life for financial stability from a man. And if they are working a lot, they have a little bit less time to raise a family, so they're not going to have as many children. And if they're trying to start a business or something like that, they may wait until later in life to have kids, which will also reduce the amount of children they're going to have. Higher access to family planning and education. That could be things like Planned Parenthood or school programs. That's going to give people more access to things like contraceptives, condoms, which are also going to then lower those unplanned pregnancies. Later age of first pregnancies. So once again, when we start moving into these more developed nations, it's not common or really accepted for very, very young children to marry and have children like it is in some other countries. So that's going to reduce the total amount of children that they're going to have over their lifetime. And then a lot of countries that are not developed still live in what we call an agrarian society, where they're agricultural based. So they need those children to help support the farms. And in our developed nations, we have less need for children to help provide some of that income through that agricultural labor. The next one is government policy. Now, this can be either forceful, so coercive, or non-coercive, which would just be like encouraging people to not have as many children. So some examples there, some countries force sterilization, and then some have voluntary free sterilization. So that could be a tubal ligation for a woman or a vasectomy for a man. And some of these places will even offer incentives, so they'll actually pay you to have those procedures done. Another example is in China. China used to have a one-child policy. They have bumped it up to two. Now, what I want you to understand about that is the government wouldn't come like steal the second child or put the parents in jail. It's just they have a very high tax that they put on families who have more than the allowed number of children. So that encourages families to not have as many children because they don't want to have to pay that tax. Some countries are going to have tax incentives to have fewer children. So they'll actually give like a tax break to people who don't have children. And then some countries even have these things that we call microcredits or loans, and they give those to women that don't have children to be able to start a business. And so those things are going to be important because not only is that going to slow population growth, but it's also going to help lift women out of poverty. So we see these things happening more in countries that have a very high TFR or countries that are worried about overpopulation. So when we look at how affluence affects TFR, down here on our x-axis, we've got the average income, and then we've got births per woman on our y-axis. So you can see that as average income increases, typically that births per woman is also going to fall. And that's because of all those things we've talked about: more access to contraceptives, family planning, educational, economic opportunities. So overall, these things tend to lead to a lower infant mortality rate. So if we have lower IMR, we're going to have lower TFR. Here's how female education affects that TFR. Also, very strong correlation there. As the average years of schooling increases, the children per woman decreases. So that leads to more education, leads to fewer unplanned pregnancies, more job opportunities, and gives women an alternative to being forced to marry very young. So our practice FRQ for today, I want you to identify and discuss two of the causes for the trend in worldwide TFR. So not only do you need to say what two causes are, you need to discuss why those two are causing that. All right, so continuing on, 3.8, human population dynamics. So we know that populations are going to have a carrying capacity that's set by its limiting resources. So we have this economist here, Thomas Malthus, who in not 1978, 1778, sorry. He kind of took a look at what was going on in the world, and he saw that population of humans was growing exponentially, but our amount of food that we were producing was very linear. So he thought that things like famine or wars being started because of a lack of resources would cause what he called a Malthusian catastrophe. So he thought that would limit our population growth and eventually create a carrying capacity for us. But what he didn't know were all the technological advances that were going to be created that helped us to increase our production of food. So today we're going to be explaining how human populations experience growth and decline. Lots of factors there. We do have some math in here. And then we're going to be describing environmental problems. All right, so once again, Malthusian, what he thought was that our carrying capacity was going to be based on food production because our population was growing faster than our food production was. So we would eventually reach a carrying capacity because we run out of food. But what he didn't know was that humans were going to create all kinds of technological advances that were going to alter Earth's carrying capacity. So, for example, the Haber-Bosch experiment created synthetic nitrogen fixation, which led us to be able to create synthetic fertilizers, which dramatically increased our food supply. Today, we have this economist, E.O. Wilson, and his theory, and the leading theory right now, is that we will reach a carrying capacity, but it won't be because we run out of food necessarily. It's going to be because we run out of enough space to be able to grow that food. But who knows? Maybe we'll be able to find a way around that, just like we did with Malthus's theory. But E.O. Wilson's estimated population carrying capacity for humans is around 10 billion, which is a little scary because we're getting pretty close to 8 billion right now. So you can see that for a very long time in the United Kingdom, food supply was very linear. But then in the early 1900s, we created that synthetic nitrogen, which created synthetic fertilizers. And from there, we've seen a huge spike in food supply. So here's our first math, okay? So our growth rate, which is just going to be a little r, that's the percent, and it's always a percent, okay, increase in a population typically per year. So as an example here, if our growth rate is 5% and we have a population of 100, that means in 1 year their population will grow to 105. So to calculate growth rate, we use the crude birth rate, or CBR, and the crude death rate, or CDR. Now, these are typically expressed in deaths per 1,000. So that comes into our math problem down here. So in our example, our global CBR was 20, so that would be 20 births per 1,000 people. And our CDR was 8, so 8 deaths per 1,000 people. So to calculate that, you take your CBR and you subtract your CDR from that. Now you have to divide it by 10 because remember, those are by 1,000, but our answer is a percentage, and a percentage is out of 100. So CBR minus CDR divided by 10 to get that ratio correct. So 20 minus 8 divided by 10 would give us a population growth rate of 1.2%. And then we can use that to figure out our doubling time, which we call the rule of 70. So this is how many years it's going to take for a population to double its size. So for that, what you do is you take the number 70, it's always the number 70, and you divide it by the percent of the growth rate. So our last example gave us a growth rate of 1.2. So 70 divided by 1.2 would say that it would take us 58.3 years for our population to double. So I want you to practice this. So if a country has a CDR of 9 and a CBR of 18, I want you to not only calculate the growth rate, but I also want you to calculate the doubling time. So pause me, figure it out, and then come back for the answer. this is what you should have gotten, okay? So 18 minus 9 divided by 10, so 9 over 10, so we'd have 0.9% growth rate. And then you do your rule of 70. 70 divided by 0.9 should have given you 77.77 years to double. So some factors that are going to affect human population growth, and we're going to talk about this a little more in the next unit, but this is building off of the unit we just completed. So factors that are going to increase that population growth are going to be higher TFRs, because then we have a higher birth rate, a high infant mortality rate. Now you might think, well, that's more deaths, so that's going to make our percent smaller, but that high mortality rate in infants is going to drive up that TFR because we're going to keep having replacement children. High immigration levels and increased access to clean water and healthcare, those are going to decrease the death rate. So all of those factors together are going to increase our population growth. And then after that, we have our factors that decrease it. So high death rate, high infant mortality rate, increased development. So we get more education, we get more wealth, we don't have as many children, increased education for women, delayed age of first child, getting married later. All those things reduce our TFR, which are going to reduce our birth rate. So that's going to bring down our population growth level. So a few ways that we can kind of measure some standard of living indicators. So standard of living is just what is the quality of life like for people in a country. That includes being able to get the necessities like food, water, shelter, but it also takes a look at some comforts, like do we have heat, electricity, do we have access to entertainment. So the first one we're going to look at is GDP, or gross domestic product, and that's a very important economic indicator, determines what the standard of living is. So this is just going to be the total value of the goods and services produced by that country. We typically calculate this per capita or per person. So it's the total GDP per the total population. And then life expectancy, that's just the standard of living, and that's looking at health, okay? This one was looking at the economy. This one's looking at the health of the population. And this is just how long are they going to live? So the average age that they're going to reach. And that's going to increase as we have access to water, healthcare, food sources. So typically, if we have high GDP and a high life expectancy, then those are typically going to be indicators of development and low population growth. So for your practice FRQ today, I want you to describe one human activity related to a rapidly growing human population that is having an impact on biodiversity. Okay, so how is the human population rapidly growing? How is that affecting natural biodiversity?
Ethan Wright, please come to the office. Ethan Wright, please come to the office.
And then I want you to also propose a solution a government could take to slow population growth. And remember, you need to be realistic with these, okay? All right, so our last section for this unit is 3.9, which is demographic transition. So that's going to be looking at how those populations are changing from having those really high TFR and really high birth rates to having kind of a drop off. So when we look at this graph right here, we've got 4 main stages. So stage 1, 2, 3, and 4. I'm just going to do a quick overview of them now, and then we'll talk about them more in the actual notes. So this orange line right here is showing population growth. And then our green line is going to be showing the birth rate. Our blue line is going to be showing the death rate. So you can see over here in stage 1, our birth rate and our death rate are both very high, but they're also very close to each other. So we don't see a ton of population growth happening. In stage 2, that death rate starts to fall, but our birth rate still stays pretty high. These are going to be a little bit more developed countries, but because that birth rate is still so high and our death rate is low, we start to see a really dramatic increase in our population size. And then in stage 3, our birth rate starts to fall. So it starts getting closer to our death rate, but there's still a pretty decent little size gap here. So our natural increase is not going to be growing quite as exponentially as it was in stage 2, but we still are going to see some population growth, just not as much. And then in stage 4, we finally see that birth rate coming down to meet our death rate. So our population growth is actually going to reach 0 or become stable. And in some cases, it's even we're going to start seeing population decline. So our learning objective for this one's going to be able to define the demographic transition. So to be able to do that, you have to know some things about the 3 types of, the 3 stages we have of the transition, and then what that graph looks like. So you're going to need to know some characteristics of those countries to be able to explain all of this. And your practice FRQ is going to be to explain environmental concepts, processes, or models in applied contexts. So when we talk about industrialization, that is just essentially the process of economic and social transition from an agrarian economy where we're based on farming, we're growing our own food. We're not like going to the grocery store and buying our food. We have to actually grow it ourselves, to an industrial one where now most of our economy is based on manufacturing. So we're creating goods and products. So the 3 kind of stages that we have here, we're going to start with pre-industrialized, or you'll often see this called less developed countries. So this is a country that has not yet made that transition from agrarian to industrial. So the majority of families are living an agrarian lifestyle where they're growing their own food, they're selling their own whatever's left over of that food to earn their income. We see a very low GDP here. We typically have a high death rate and a high infant mortality rate because of lack of clean water, lack of access to health care. And so those are going to be those countries that have that high TFR because we're going to be replacing the infants that are dying to help with that agricultural labor. Then in our industrializing or developing nations, we're in between these 2. So we're not pre-industrialized, but we haven't fully reached our developed level. So here we're going to starting to see our death rate and our infant mortality rate going down. We're going to have a rising GDP, but some portion of our population is still going to live in that agrarian society. And then our last one is the industrialized and developed. So this is, we're through the transition now. These have a very low death rate, very low infant mortality rate because we've got clean water, we've got healthcare, we've got a high GDP. And because of all those things combined, we're going to have a low total fertility rate. So this map is going to show you the development status of different countries throughout the world. So you can see our blue are going to be our developed countries. So the United States, Canada, Japan, a lot of Europe, our developing countries. You can see that's where most of the world is. Most of the world has not made it all the way through that demographic transition yet. So we've got Russia, pretty much all of South America, some of Africa, and then our least developed countries. So that's going to be most of Africa right here, some Southeast Asia. So we're going to talk about some characteristics of each of those and what that stage of transition means for them. So stage 1, our pre-industrial, so high infant mortality rate, high death rate. We don't have clean water. We don't have a stable food supply. We don't have access to health care. We're going to have a high total fertility rate because of all those things we talked about in that last unit. So there's not a lot of education for women. There aren't many contraceptives or opportunities for family planning. And then once again, that need for child agricultural labor. So in these countries, we're going to have a lot of very poor, these are going to be our very poor countries. And essentially, when we look at these, there's pretty much no country that's still in phase one, truly in phase one. They're in their early developing stage, but it's very early. They're not fully pre-industrial. Then we All right, then we're going to have stage two, where that's going to be our industrializing or our developing nations. So here we're going to start seeing some modernizations happening. We're going to be able to have clean water, healthcare. We're going to have a stable food supply, and we're going to start seeing that infant mortality rate and that crude death rate go down because of access to those things. But in this stage, even though our death rates are going down, the total fertility rate is going to stay high. And that's going to be because we're going to still have some lack of education opportunities for women compared to men. We're going to have a need for that agricultural labor still. And then we have what we call population momentum, which is a generational lag. So it takes time for those societal changes to spread throughout the generation. So this typically is going to take some decades for this to happen. So here we're going to see rapid growth because we've got a high birth rate still and a declining death rate. So some economic or societal indicators here, that's going to be low per capita GDP, a shorter life expectancy, high infant mortality, high TFR, and then we're going to have very low literacy rates and school life expectancy for girls. Some examples of countries that are in this stage right here would be places like India, Brazil, China, Afghanistan. Then we have stage three, where we are developed and industrialized. So here we've got a very modernized economy and society. This is going to increase family income. So because of that, TFR is going to decline because of those educational opportunities, which tend to lead to delayed age of marriage and first child, focused on educations and careers, access to family planning, contraceptives. So here we start to see slowing growth rate as our birth rate drops closer to the death rate. Now, we're still going to see some growth, but it's going to be very slow growth. This is going to have a pretty high per capita GDP with a long life expectancy, low infant mortality rates. We're going to see that TFR near the replacement level of 2.1. So we're only having enough children to essentially replace the parents. And then we're going to have a higher literacy rate and school life expectancy for both males and females. So countries like this would be the United States, Canada, and a lot of Europe. And then we also have what we call post-industrialized or highly developed nations. There aren't a ton of these in the world, okay? So these are going to be highly modernized and they're going to be very affluent countries. So this is where in that graph, our birth rate and our death rate start to come pretty close to each other. So that TFR is going to keep declining as families become more wealthy and spend more money on education and time on education and careers. We're going to see that increased wealth and education. That's going to bring with it even more use of family planning and contraception. So here we're going to see our birth rate dropping either to the same level of CDR, which would give us no growth, so stable growth. But eventually what we see in these nations is that it's going to drop even lower than the CDR. So we're going to have negative population growth. So our population is going to start getting smaller. This is going to have very high per capita GDP, the longest life expectancy out of any of the groups. Our TFR will be below replacement level, so women will be having less than 2 children on average, and this has the highest contraceptive use rates in the world. We tend to see a lot of elderly people in these societies, so this is going to be places like the United Kingdom, Germany, Italy, and Japan. So this is a pretty good graphic here. It still has all this going on that we talked about, okay? Make sure you understand that stage 1 is pre-industrial, 2 is developing, 3 is developed, and 4 is highly developed. But one thing I like about this one is that it also includes our age structure diagrams that we talked about. So in stage 1, I just want to go through these and kind of talk about those diagrams before we move on. So in stage 1, our graph down here has the highest proportion of people in our pre-reproductive stage. So I know we said last time that if pre-reproductive was higher than reproductive, we would see population growth. However, that's not quite the case with this one, because if you look at what happens to the pyramid as you go up, it's like gone, okay? And that's because you're going to have a lot of these people in the pre-reproductive stage are not going to make it to the reproductive stage. And then if they do make it to the reproductive stage, they are not going to be able to reach the post-reproductive stage. And then in stage 2, as that death rate falls, but our birth rate stays high because of that lag, we're going to start seeing very rapid increase, so a lot of population growth. In stage 3, we're going to start seeing that birth rate finally start to fall because we've pushed past that lag there. And so now we start to see essentially our base here is still wider. So we're still growing, but we are not growing as quickly. And then lastly, in stage 4, it's nice and even on the sides. So we're going to see that natural increase falling and then becoming stable. So make sure you can kind of match up these graphs with our stages of development. And then your last practice FRQ for this unit, I want you to use this graph right here. And I want you to identify the stage of this graph in which a population is going to grow the fastest. So where are we going to see the most amount of population growth, and explain why. So don't just tell me stage 1, 2, 3, or 4. Why is that? And besides that population growth rate, I want you to describe one economic or societal indicator of a country that's in this phase. So if you think they're in stage 1, you would tell me things like they don't have access to clean water, they don't have high education levels, things like that.